Okay, this is attempt number 2 to record 1, 4, 7, 10, etc. Didn't work the first time. So, here we go. Function f is defined by f of theta equals cosine of 2 theta, which the following is an equivalent expression for f of theta. So, cosine of 2 theta. I remember that cosine of 2 theta is cosine squared minus sine squared. That's my first go, but that's not one of my answer choices, so I was like, hell, heck. Sine squared plus cosine would be 1, so that's not it. 2 sine cosine, that's sine of 2 theta, so I don't think that's it. The question is, does it become one of those when I use this sine squared plus cosine squared as 1? So if I will replace, I don't know which one will work, so let's just pick one. Let's replace cosine squared with 1 minus sine squared. Cosine squared to be 1 minus sine squared. So 1 minus sine squared. And then the original minus sine squared. And now I've got 1 minus 2 sine squared theta. There's 2 of them. And so that is answer choice C. So that used a couple of Pythagorean or PreCal identities, trig identities to get there. Number 4. The function is secant squared plus tangent. Where does that equal 1? On 0 to 2 pi. So let's see. Secant squared x plus tangent of x equals 1. This is, I can't do anything with that right now, but I know that tan squared plus 1 is secant squared. So I'm going to replace secant squared with tangent squared plus 1. Oops, tangent squared x plus 1 plus tangent x equals 1. You subtract the 1 and it goes away. And then I've got tangent squared x plus tangent of x equals 0.
Are you this one?
Alright, let's factor out the tangent, or one of the tangents. That leaves tangent of x plus 1. So tangent of x equals 0, and tangent of x equals negative 1. Let's see, tangent is 0 where sine is 0, that's how I remember it. So that would be at 0 and pi and 2 pi. And let's be careful, both of those, or all three of those, are in this interval. So make sure you're checking, especially those endpoints are okay. Tangent of x is negative 1 in the second and fourth at the over 4s. So that's 3 pi over 4 and 7 pi over 4. And then answer choice A puts them in like numerical order rather than like grouped order, but it's answer choice A. C is tricky because C is sort of correct, but it's only correct if you had all the answers. So C is a very good distractor there. Number 7. The function f is given by this thing. What is f of 3 pi over 4? Well, that means whatever is in for x goes in for the other side, for x and the other side. So f of 3 pi over 4 is the sine of 3 pi over 4 plus 4 pi over 3. And now I recognize why this problem is set up this way. It's because it's a sum sine problem. So that's sine of the first, cosine of the second, plus the other way around. Cosine of the first, sine of the second. Let's see, sine of 3 pi over 4.
Let's say merchandise is open at the store. If you could please go down there, they have candy and snacks at the store.
Sine of 3 pi over 4 is root 2 over 2. Cosine 4 pi over 3 is negative 1/2. Cosine 3 pi over 4 is negative root 2 over 2. Sine of 4 pi over 3 is negative root 3 over 2. So negative root 2 plus root 6 all over 4. And that's not exactly written like that, but that would be the same thing as answer choice D. Number 10. What are all the solutions to g of x equals 3? So tangent of x equals 3. That is not a unit circle value, right? Like square root of 3 would be, root 3 over 3 would work, but just 3, that doesn't work. So we'll need to do arctan of 3. I kind of want to visualize where that would be. If tangent's positive, that's in the first and third quadrant. Arctan of 3 would be this opening. So that's why arctan of 3 keeps showing up in these answers. But if I want all the solutions, then I need to rotate pi to get to the next one, and then pi again, and then pi again, and then pi again. So I can rotate pi as many times as I like. So arctan of 3 plus pi k will catch all of the places where the tangent is 3. Number 13. The number of moose in a park is modeled by this function, where t is the number of days since January 1. Which of the following is true? So basically, where is it decreasing? I don't want to do like the details of this. I think I want to just know that there's no phase shift. My midline is at 150. No, my midline would be 174. My amplitude would be 150. But maybe most importantly is the shape of a sine wave. Looks like that. And with that, the period is 365. So this is the course over a year. Now, that's probably enough for me to get this right, because halfway is, 183-ish. Half of that is 90-something. Half of that is 270-something. Somewhere in there. So it is decreasing from 90-ish to 270-ish. So I look at my answer choices, and there's, we don't have to get too precise. It's the only one that's reasonably close. 92 to 273 is where the population is decreasing. Number 16. Where f, the intersection of f and g, well, that would be where f equals g. So 1 plus 3 secant of x equals negative 5. 3 secant of x equals negative 6. Secant of x equals negative 2, which I don't really want to mess with. I'd rather say cosine of x equals negative 1/2. And then I need to be careful about where I'm allowed to look. 0 to 2 pi. So let's see, 0 to 2 pi. Cosine is negative there and there. So that'd be 2 pi over 3 and 4 pi over 3. Answer choice C. Number 19. What are all the values between negative pi and pi? Oh, I need to be careful here. So this isn't sort of not my normal look. That means I got to look forward pi and back pi, for which 2 cosine is greater than negative 1 and 2 sine is greater than square root of 3. So I need to find both of those and basically look for the overlap. So I'll need to do a number line from negative pi to pi, really for both of them, and then see where they overlap. Alright, so 2 cosine theta is greater than negative 1. I'm just going to switch that to an equal sign because I'll worry about the greater than and less than with the number line and intervals. Cosine is negative 1/2. This was like the last problem we did. at 2 pi over 3. Although I have to be careful because I don't want to use 4 pi over 3. That's not in my interval. I need to go backwards and use negative 2 pi over 3.
Don't forget, the merchandise store is open in the sports commons. We have candy, we have fun, there's merchandise to buy. Come look, maybe buy something.
So there's my cosine graph. I guess let's check 0 would probably be the easiest thing to check. 2 cosine of 0 greater than negative 1. Question mark. Cosine of 0 is 1. 2 is greater than negative 1. That's true. So we will shade all of this. And we won't shade there, and we won't shade there. Alright, now let's do the sine piece, and we'll look for the overlapping shades. So 2 sine theta greater than root 3. Sine theta equals root 3 over 2. That would be at pi over 3 and 2 pi over 3. Also open circles. I could check pi over 2. It'd just still be easier to check 0. Let's check 0. 2 sine of 0 is greater than root 3. 0 is greater than root 3. No, that's not true. So that's a no. That's a yes. That's a no. So if I look at those together, the overlap happens on the right end at 2 pi over 3, on the left end at pi over 3. So the only spot where both of those things are true is between pi over 3 and 2 pi over 3. That is answer choice D. Alright, that concludes that third of the video. Go find the other videos if you need the other problems.